afternoon. Welcome to our Airco Boiler live stream seminar. Our session today will be approximately 45 minutes for the seminar portion and 10 to 15 minutes for questions at the end. If you have a question, please use the chat button to ask the question, and we will be sure to cover it at the end. Our trainers today will be members of the team Deppmann. Dylan Stark from our Grand Rapids location and Ron Bonak from our Cleveland location. They are both factory trained and hold Airco Master Technician credentials. If you plan to work on any piece of equipment, please ensure you are qualified to do so. Before proceeding, please lock out and tag out any sources of energy and wear the proper PPE when doing the work. At this time, we are going to switch over to the training, and Ron Bonak will start off our Airco training.
Thank you, Nicole. Good afternoon, everyone. Thank you for attending our seminar today. Today, we're going to go over the benchmark BMK 1000. This is the benchmark 1 million BTU fire tube boiler. So, let's go ahead and get started. Let's open it up and see what we got inside. They've changed the covers a little bit, so don't just pull these guys because it won't come off, okay? Levers lift up. They quarter turn in, and you simply just pull the front cover off. And there's the inside of the boiler. So the first thing we'll look at here is our power supply. We open up this cover here. Our power comes in from the top into the breaker supplied by the manufacturer. We have our connections for neutral, ground, our fuses, DC power supply, amplifier, and low voltage step-down transformer. From there, we step down into our display. And from the display, you can actually see several things. Our inlet temperature, water inlet temperature. Of course, we don't have any water coming in, but currently 72, and our outlet is 74. Some of those are also on the screen here as well. You can see the inlet temperature of 72. Outlet is 74. We currently have a 160-degree set point. The boiler obviously is disabled. As you can see, it says all boilers off. Our current firing rate is 0%. Our flame strength is 0%. Our target rate is 0%. That's because the boiler is not energized right now and it's not firing. We also have our exhaust temperature and our air inlet temperature. Enable disable button. This will start and stop the boiler. And then we have a series of keys here as well that will allow us to scroll through menus and different variables and settings inside of the controller, inside of the Edge controller. We also have our low water cutoff, test, and reset buttons here. So test button, reset. If you ever perform a test or you ever trip a low water cutoff, you will need to correct the problem, manually reset it here before clearing the fault here. If you just simply try to clear the fault, it will still stay there unless you do a manual reset. From here, we're going to look at some other components in the system. So up here we have our rib relay. This is our isolation relay. This may be used as a pump relay if we're doing a primary, secondary boiler plant. So we could use this to energize our boiler pump. Our air fuel valve. Our air fuel valve starts with an air filter, which is a K&N filter. This filter is serviceable, cleanable, washable, replaceable. So a couple things with that. If you're going to take it and clean it, K&N makes a recharge kit, and the recharge kit actually has the cleaner and the oil in it. This is a process, and you'll want to let the filter dry completely 100% before putting the oil on it and reinstalling it back onto the boiler. I recommend having a second filter just in case. You can replace it, install it, take this one out, clean it. Next time you need to replace it, you already have it ready to go. So that's connected to our air fuel valve. We talked about that air temperature sensor on the front display. We were seeing that air temperature reading. This is our sensor right here. And one of the things I want to note about this, we're going to look at a couple sensors. This sensor is going to be the same as several of the other sensors that are located on the boiler as well. So one sensor fits multiple different locations with the same resistance. Air fuel valve cover comes off. The air fuel valve contains potentiometers, two potentiometers in here. There is an ignition switch back here. It's a 2-wire switch, proving. There's a purge switch over here, which is the same switch as well. This is our stepper motor, which actually rotates our air fuel valve. Internally inside of the air fuel valve as well, we have a butterfly. We also have a Teflon sealing ring, and we also have a gas shutter and a gas plate in there as well. Important to note that this is not a repairable component. If there's anything wrong with this air fuel valve, you'll have to replace the whole assembly. Sitting on top of the air fuel valve would be our blocked air switch. So in the event that our filter was completely dirty and we weren't getting any air through here, this switch could potentially be open. If the switch is open, you'll get a blocked air fault and the boiler obviously will not run. 4.5 inches of water column is what the switch is set at. Air proving switch, our air proving switch is set at 0.16 inches of water column, very minimal. So again, if the blower doesn't run, the air proving switch doesn't prove, the boiler will never go in to the rest of its sequence of operations. Also up here on the top is a little, you can probably see this little, hopefully you can see this little mirror here and this little sight glass. So that is, that's there so you can actually see the flame presence. When the boiler does ignite, you're able to see what that flame looks like and prove that you have flame up there. Ignition transformer is located right here on the top railing of the boiler. From there, we have our SSOV. This is our safety shutoff valve or our gas valve. So safety shutoff valve also contains gas pressure switches, which will be low gas pressure switch. And over here is a high gas pressure switch. These both have factory settings as well, and they're sealed. So please do not adjust them. If they're out of range, the best thing to do is replace them, or if they fail, just replace it. This, I believe, is set for 2.6 inches water column. And the way you can test this device actually is just simply start closing off the gas valve with a manometer hooked right here. Take this plug out, put your manometer in here. Slowly start closing off the gas. And as it drops and it gets below 2.6 inches, the switch will open and the boiler will shut down on a gas pressure fault. Same thing will apply for the high gas pressure switch. Difference is going to be there is we would take this brass nut out here of the SSOV, top of the SSOV, and we would start increasing clockwise, turning the screw in, increasing the gas pressure until we get above 4.7 inches on our high gas pressure switch, and that will allow us to trip the high gas pressure switch, and again, we will go into a gas pressure fault. Make sure, obviously, if you do that you set this back and you verify where your setting is before you make any adjustments here. Bring it back to where it was after you've tested your device. Coming around to the side of the boiler, this would be the left side of the boiler. Again, you can get a little bit better look at that gas pressure switch. Some of these, depending on model dependent, will be automatic or manual reset. These happen to be automatic resets on the 1 million. This would be our current sensor, which is sensing spark. So if we don't sense spark, obviously, we'll go into a fault as well. Doesn't necessarily mean the current sensor is bad. There could be something else going on. This would be our internal gas shutoff supplied by the manufacturer, and this comes into the other side of the air fuel valve. So we have the air coming in here, and we have the gas coming in here, mixing together, going through our blower, which we'll take a look at a little bit when we get around the other corner there. You'll be able to see that a little bit better. Pre-mixed down into our fiber mesh burner. This would be our dual temperature sensor. So this is our manual reset and our operating limit are both tied into this particular well here. This one up here will be our outlet temperature sensor. This is also a dual sensor. So this is outlet, and this is also the love control, which is on the front. And when we come back around, I'll show you where that is too. One of the things I'd like to note on this in particular is if you see, hopefully we can see this here, there's some red coating on this connector here. Okay, so the red obviously to me would be hot water. That would be your outlet side. That's kind of an indication that's your outlet. Coming across the header, we have our tridicator or pressure temperature gauge, and we have our pressure relief valve. Pressure relief valve testing, basically it's just a trip lever. So trip the lever, make sure that the relief valve actually does relief and that it reseals. Please don't ever remove this tag. It's very important that we don't remove this tag. The inspectors are going to want to see this when they're doing their CSD1 inspections. And also, if you need to replace this, you're going to need this information. You're going to need to know what size your inlet outlet are, what your BTUs are, and what your pressure rating is. Coming across the header, down just below it, this will be our low water cutoff. Our low water cutoff sits right inside of our supply header. It also has a capacitor connected to it to bleed the voltage off of it. This can be tested again with the front panel like we talked about. We also can do a resistance test on this from the low water cutoff probe to P5 19-pin connector, pin number 6, I believe it is. Resistance from there. So that's on the back of the Seymour. That P5 pin connector is on the back of the Seymour, on the back of the Edge Control. Okay. This happens to be set up in a situation where we would be looking at doing a BST, and we have a Bolier isolation valve supplied by the manufacturer with a built-in end switch. This would be something we'd like to use for BST when we're doing a variable primary. If we're doing variable primary, obviously the reason behind that is we want to make sure we have flow through boilers that are on and no flow through boilers that are off. So we're not mixing that. The manufacturer sends the wiring harness with this little jumper in it. So in the event that you might be doing a primary secondary and not using the actuators, you would just leave this jumper in, and that would make your connection for your end switch. Coming around to the back bottom side of the boiler, just like we had that supply sensor, you'll notice that looks pretty similar to our air sensor. Again, this won't replace the supply sensor because that's a dual temperature, but this can be used as a return sensor. It can be used as a flue temperature sensor, and or it can be used as the air temperature sensor on the air fuel valve. Remember we talked about the red coating. This is blue, this is yellow. Blue would be your cool water, right? So it's your return water. Yellow would be your exhaust. So if you ever happen to disconnect these and you're noticing temperatures don't look right, you may have reversed these. It's very easy to do if they're both disconnected. Our exhaust manifold. So our exhaust manifold is bolted to the bottom of the heat exchanger. All our condensate and our flue gases travel through here, and they'll come out through here into our condensate trap. And our condensate trap has a poly ball in there. A poly ball seals the condensate, the flue gases from basically escaping into the atmosphere or into the mechanical room. Dylan will kind of talk a little bit about maintenance on that. And out of there, we would generally go into our acid neutralizer to neutralize that condensate before it hits our floor drain. We come out and drop into our floor drain there. Back up towards the top, continuing around the back side of the boiler, we have our Watts float style air vent. And this is to relieve the air from the heat exchanger. So we don't airlock the heat exchanger and we're getting flow. Obviously no flow through one of these is a bad scenario, bad situation. They'll start dancing on the floor without any flow. So be careful, make sure you've got the air out. This is our pilot solenoid. Our pilot solenoid is connected to our fan jet style igniter. So basically, the pilot solenoid opens, sends a flame down, we spark, we ignite that pilot, and then we light the main burner off of there. One of the things important to remember with the fan jet igniter, if you replace this igniter with one off of your truck or from the factory, I would recommend that you put a mark on this somewhere and mark it to the top plate of the heat exchanger or your burner plate. Make it easier for you to reinstall it. They give you clocking washers. The clocking washers are designed to try to get it as close to the factory position as possible. You may use 1, 2, 3, or you may use none to get it back to that position. Just imperative that you do that. And also make sure they supply you with the grease. Anti-seize. Put the anti-seize on it, please, so that it's easier to get it out next time. They will get hot, and sometimes they can be a real bear to get out if you're not putting the anti-seize on them. So all comes in the kit. O2 sensor right here, so we can actually read our O2 readings on board. And then our flame sensor would be here. 2 wires or 2 screws to pull that out. And this is our blower motor. On this particular model, the blower is mounted directly to the burner plate. You get to some of the larger models, this will be off of the top of the heat exchanger, and there's actually an intake elbow connecting the blower to the top of the burner. As we come around the other side of the boiler, again, because we have set this up in BST, and we've basically made it a manager for testing purposes today. We've wired in the header sensor just temporarily. The header sensor is a 1 k ohm at 70 degrees Fahrenheit, and it's 2.2 ohms of resistance for every degree above that or below that, I believe it is as well. So this would typically be mounted depending on what you're running. If you're running a variable primary, or if you're running a primary secondary. If you're running a primary secondary, it would be downstream of the last boiler after your closely spaced tees in the main header, supply header. If you're running a variable primary, it's still going to be downstream in the main header of the boiler, last boiler. Outdoor sensor. Outdoor sensor is also a 1 k ohm at 70 degrees. Recommend mounting this outside, out of direct sunlight, off of anything that might be hot and be able to potentially transmit additional heat to this, causing you to get incorrect outdoor temperature sensor readings, which will change your outdoor reset schedule, of course. Coming back around into the front of the boiler, we talked about the dual temperature controls and our manual resets and operating limits. So our manual reset is actually right here. And this does have to be manually reset. So if you get a fault on a high water temperature, high water outlet temperature, you will probably have to reset this. You can't just clear the fault on the screen. This would be our operating limit, and this is our love control. In addition to that, in the front of here too, they also give you this nice little compartment here for IO manual and the combustion calibrations that they did at the factory. So everything is in here that you need. I recommend leaving it in here for reference for the future. And all of your pertinent information will be located on the sticker just below that. Model, serial numbers, BTU ratings. And in addition, there's also the tag on the boiler heat exchanger. So this is your H stamp tag, as well as your model, serial number, maximum allowable water temperature, maximum allowable pressure. And then we come up to the I/O board. So this is an input-output board. Sometimes it's just pass-through for communications or for specific safeties. So a couple of things I'm going to talk about are header sensor. So this is where we would land our header sensor. And it's actually marked up here for you, header temperature sensor. The board is all marked, and there's also a sticker below it. If you can't see some of this because of the wiring going through here. But right here is a red and blue wire at the bottom. These wires are for checking your output voltage to the blower. So if you know what speed the blower is running at, or what speed you think it should be running at, you can simply go ahead and put a meter across the two of these and take a DC voltage reading on your meter, and it will give you that voltage output. It should match the voltage output that the boiler is specifying. If not, something's wrong. So you may have to start looking digging a little bit deeper into what's actually causing that problem. Could just be a bad blower motor, could be a number of different things. So that's how you'll check that. We have fault and status relays on here. These are the fault and status relays. And those, I'm trying to keep some of the stuff out of the way and keep my fingers out of the way here, guys. So those fault and status relays are right here. Common, normally open, and normally closed. So that allows the building management to wire them to their likings. And we have our remote enable disable. If you can see this green jumper here, that green jumper right now is in play. Generally that would be where the building management would land their start stop. Please put that through some sort of an isolation relay. This is a powered set of contacts. So if you apply power to those, bad things happen. Boards blow up, burn out. And this is also where we connect our RS-45 communication wiring. So this would be our daisy chain if we were cascading multiple boilers together. In this case, we're just using the one today. So our RS-485 is hooked in here from boiler 1, and that goes over to our field server protonode gateway. So this allows us, if it's set correctly, if all of our variables are set correctly in here, this allows us to communicate with the building management system in a BACnet IP or a BACnet MSTP. If it was LANWorks, we can do that as well. Different gateway, just be aware of that. It won't communicate with the same gateway. So so that we know on our end, from the boiler at least to the gateway, whether we're communicating, this is what we're looking for. We're looking for a slow flashing run light, rapidly flashing RX and TX, which are receive and transmit lights, and a solid green power light. Anything other than that, profile may not be set up correctly, and you may have to look at resetting up that profile. So just verify you got everything set up correctly. Also, one other thing to note with the field server, don't power this off of 24 volts from the boiler. We would really like you to have a separate 24-volt power source to this. Most of the guys will mount this into their building management panel anyway, so, and bring their RS-45 communication back to it. Other than that, Dylan's going to go a little bit deeper into the BST sequencing of the boiler and some of the maintenance. So thank you guys, and with that, I'm going to turn it over to Dylan.
Thanks, Ron. Yeah, I'm going to start out by going through the operation of the boiler itself, the firing sequence. What it's going to do is once we are enabled from our building automation, which is where the green jumper would be, once that's enabled and the system has a call for heat depending on set point and how that's all set up, whatever boiler is determined to be the lead boiler will fire. The first thing that it will do is it will go through an auxiliary start delay if you have the isolation relay installed. With that isolation relay, you'll put in a 120-second delay, and it'll go through that 2-minute timer. After the 2-minute timer and the valve is in the proper position and open, we will go into our purge counter. The blower will come on full speed, and the airfield valve will open, and we'll push air for 30 seconds through the heat exchanger. That's used to purge out any possible gases from the last firing sequence. Once the purge counter is done and we've purged for 30 seconds, we'll go into our ignition trial. The ignition trial starts with the blower drops down to about 30% fire rate, and the igniter starts sparking. The screen will tell you cleaning igniter. That will last 7 seconds. That has two purposes. The first is it lets the spark get good and strong so that if you happen to be building a carbon bridge, the carbon bridge should blow apart and keep itself cleaned off. And the second function, Ron showed you the current sensing relay on the backside. We're sensing the current through the ignition transformer so that if it's not between a certain window, which is 0.1 amps and 0.4 amps, it knows there's an issue with either the igniter or the ignition control. So it'll stop the firing sequence then so that we don't have a hard light off. Once we've proved our amp draw across our ignition transformer, it will then open the voltage to the pilot solenoid and allow the pilot solenoid to allow gas through and light the pilot. And after a 2-second delay, it will send power to the SSOV and open main flame. After main flame is open, it has approximately 2 seconds to prove flame on the flame sensor. Once it proves flame and everything's happy, it'll go into a warm-up period if it's the first time it's fired for a while. And once the flame is established and stable and the boiler warms up, it will then be released to operate based on set point and whatever is controlling it. At that rate, the boiler will ramp up. It'll ramp up at approximately, for every percent, it'll take 2.5 seconds. So it ramps up slowly to get the loop up to temperature. And then once the loop is up to temperature, the boiler will start ramping down to try to keep the boiler running to maintain the proper heat load. So we like these to stay running for as long as possible, just nice even heat. However, if you do reach your set point or slightly go over it, the boiler will shut down, the heat demand will drop, and then the SSOV will shut, flame will go out, and the boiler will go into its standby position. At that point, you may notice that the blower is still running. They use a standby voltage on these. As long as they're still in standby, it'll send 2 volts to that blower so that it constantly keeps pressure in that flue pipe in case there's several boilers. And just because this one's not running, we don't want, if the building's in negative, we don't want to suck flue gases in from the stacks that are next to it. From there, I'm going to go into how our BST works. If we have multiple boilers, they will be daisy chained, like Ron said, off of RS-485 wires. So you have multiple boilers together. This boiler would be the managing boiler. That's how we would set up. That's where the header sensor and outdoor air sensor would be tied to. The managing boiler will determine which boiler is lead based on run hours. It cycles the lead boiler based on looking at everybody's run hours and keeping them even. So it'll fire the lead boiler first, whichever one is lead, and it'll go through the whole firing sequence that I just went through with you. And then once that boiler is through its warm up and released, it'll ramp up. And once the lead boiler hits 50% fire rate, it'll initiate the second boiler. That's all, like I said, determined within the managing boiler, which boiler would be next. And then once that boiler goes through its firing sequence and establishes flame and is released to run based on set point, both boilers will come to an even set point, which is usually in the 30% range, and they will ramp up together. Once both boilers hit 50%, again, it'll bring in the third boiler. You can run up to 16 boilers in a boiler plant with the Airco Edge Controller. And then the process as the loop warms up is the same in reverse. It'll slowly start ramping them down, and when there's not enough load for 3 boilers, it'll shut off 1 boiler, and the 2 boilers that are still running will absorb that amount of load, and it'll bring the fire rates down evenly. I'm going to show you in the controls here what the main screens look like. From our home screen, this is what you're going to see for a home screen. If you go into unit status, this is the menu we're going to start with. Unit status screen, this is what Ron went through earlier with all of our status of this 1 boiler, set points and whatnot. You got a right arrow here. If you go right, that's going to show you your plant status. So if you have multiple boilers, it gives you all that pertinent information. It gives you how many units are available, how many units are firing, just tells you what the whole boiler plant is doing. To go to the right again, this is where it gives us our BST Cascade status. Like I said, it can do up to 16 boilers, and if we had boilers wired in, they'd all be flashing like this. Obviously, this boiler we have disabled because it cannot fire in our training room. But it would populate every one of those squares, and it let you know whether it's disabled, whether it's an alarm, whether it's on standby. And so you can get a good overview of what each boiler is doing right from this one screen if you have up to 16 boilers. We go over again. This is a secondary screen to that screen. It tells you what the isolation valves are doing. And how the BST operates the isolation valves is when none of the boilers are running, all valves will be open. So up to 16 boilers, all of them will be open. Once it fires a boiler and the boiler proves flame and is released to run based on set point, then every boiler that is not firing, those valves will close. And this screen should show you that. That way you can troubleshoot if you've possibly got a bad valve or any number of things along that way. So that's what this screen does here. The next screen gives you your runtime hours and cycles based on just on this boiler, how many hours, how many cycles, and it gives you an average cycle per hour. Obviously this one has not been ran, so it doesn't give you an average yet. The next screen is the unit event history. This is the alarm log just for this boiler. So if you get into this screen, you can see the time and date and what fault happened just for this boiler. That'll help you troubleshoot many things. And since this boiler is the manager, it also gives you a plant event history. So what will this one do is you'll see the alarms from all 16 boilers on this screen. So this will help if you're getting gas pressure faults. You know, if you see 4 boilers all at the same time get a gas pressure fault, it might be easier to troubleshoot that maybe you had a system issue, you know, with the building or just more troubleshooting help. Obviously, there's not much in this because we have not ran this boiler. The last screen is, it'll give you the last ignition status. This is the screen that'll come up as the boiler is going through ignition, and it'll populate each of those squares and tell you the timing and what's going on at each point. And once the boiler fires, this screen stores with that information until the next firing sequence. So if you come in and the boiler's an alarm, you can come to the screen and see what happened during the ignition sequence and use that to help troubleshoot. And from there, it brings us back to unit status. I'm going to go into a little bit of the maintenance and also show the isolation valve and how we set that up. If you're using the isolation valve, we showed the end switch ties in at the IO board over there. The S1 switch, this is the switch we're using for our end switch. If the valve is in the open position, which it is right now, we can tell by the shaft, then the end switch should be adjusted to about 9 o'clock. If this was a clock, it should be pointing at 9. If the valve is closed when you set it, you see it points towards 3 o'clock. And you hear the valve is moving because it should be open right now because the boiler's not firing. So I'll get into a little bit of the maintenance that we go through. Semi-annually, Airco would like you to check the flame sensor and igniter and clean the condensate trap. As Ron pointed out over here on the top. So semi-annually, you can clean the flame sensor, which is just the 2 Phillips screws, and the screws are offset, so you can't put the sensor in backwards. There's only one way it'll fit. And same with the igniter. You can take off your compression fitting and your plug and pull the igniter out and clean it. And also semi-annually, I would also clean the condensate trap, because depending on the environment down here, it can get a little dirty. Definitely want to clean the condensate trap and neutralizer semi-annually, especially if the boilers are running dehumidification and running all summer long. You'll definitely want to do that twice a year. As for the annual maintenance, Airco sells an annual maintenance kit, which includes a replacement flame sensor, a replacement igniter, and an O-ring for the condensate trap. Annually, what you'd want to do is obviously clean or replace those depending on condition of them. Clean your trap again, semi-annually and annually, obviously. Clean the trap and neutralizer. And then you'd also want to do all your safety device testing and CSD1 testing, especially here in Michigan. That's a good time to go through and do all your CSD1 testing. You should adjust calibration at least once a year to make sure your boiler is running at proper efficiency. That'll keep it running and keep it condensing properly and give you a long life on your boiler. Then the biannual maintenance that Airco recommends, the kits include the same things, the sensor and the igniter and the O-ring, but it also includes gaskets for the burner, because every 2 years they want you to pull the burner, which on this model, you would remove all your ancillary devices, your igniter, sensor, and all that. And you unhook your gas line, and you would remove the whole blower assembly and air fuel valve. On the larger models, there's an air plenum that you remove. It's a little easier because they're larger, but this is a smaller model. And then you remove your bolts around your burner plate, and the burner will pull up directly, vertically up out of that hole. I have a burner here out of a larger model. It's obviously not out of this model, just so you can see what it looks like. It is a typical low NOx mesh burner. When you pull it, you want to inspect it, make sure there's no gashes, no scratches, no holes. Anything like that can cause a hot spot and cause your efficiencies and your COs to go up. Your flue gases won't be burning properly. Generally blow it out with compressed air, nitrogen, something along those lines. If for some reason it does get very dirty, somebody forgot to put the filter back on or such, you would definitely want to possibly clean it with water, possibly a light soap detergent. You can contact us if you need more recommendations on that. It's very rare, shouldn't need to do it, but if you do, make sure you get it dried very well before you put it back in and walk away from it. You don't want to put it in wet and not run it and have anything rust or any issues like that. Also, in the biannual maintenance, well, we're getting back to the neutralizer, sorry. The neutralizer kits, this is out of a larger one than the one we have here on the floor, but we do sell the neutralizer kits if you need to refill the neutralizers with the limestone material. Just get a hold of us and let us know which model you have, and we can get you a kit to refill that. Like I said, and in the 2-year kit, it does come with all the gaskets needed for pulling that burner, as well as a replacement low water cutoff probe that is right here and capacitor. So the 2-year kit should include all of that. From there, I just wanted to real quick show where that isolation valve wires in. The isolation valve is a 0 to 10 volt valve. The power wire is right here with a white, yellow, and red R. That's 10 volts closes the isolation valve. 0 volts causes it to open. And then the end switch is tied into our delayed interlock. That's why I said you set that 120-second volt or 120-second timer to give it 2 minutes to fully open or fully close as it needs, and it'll prove where it needs to be. The last thing about to check out is when you're doing your maintenance, if you're losing flame signal and you're not sure why, just to cover the basics, you can take a meter that measures microamps and you can wire it in line with your flame sensor. Take your flame sensor boot off, wire it in line, and once the boiler fires, you can read exactly what the boiler is seeing for microamps. And you can determine possibly if you have a bad flame sensor or a dirty flame sensor. That'll help you prolong the life of it and see exactly what's going on inside of that boiler. And with that, I believe we are going to complete our maintenance and send it back over to Nicole.
At this time, we'll review the questions that came in from our chat feature. We had a couple that came in. So the first question is, can the factory provided and installed circuit breaker act as the main NEC approved electrical disconnect for the unit?
I'll let you answer that one, Dylan.
Well, I know in Michigan, it will not work for CSD1. For CSD1 standards, you have to have a lockable disconnect outside of the unit within arm's reach. So since this is inside the unit, it will not pass for CSD1. And this breaker is not lockable. Most contractors mount a lockable disconnect to the boiler or on the wall behind it. So it's more of a service switch, I guess I would call it. Power the boiler down. But you still want to lock out, tag out at another source.
Okay, thank you. Our next question that came in is, what is BST?
Oh, go ahead.
So BST is a boiler sequencing technology. That's what Airco uses as our terminology to refer to a boiler plant that has multiple boilers and are sequenced together based off of the master. So essentially with the boiler sequencing technology, it goes a little bit back to what Dylan was talking about as far as how the boilers are staged and destaged.
All right, thank you. The next question that came in is, this seminar was on the benchmark with the Edge controller. What is the benchmark platinum with the Edge do that this benchmark cannot do?
No, take it. The benchmark platinum actually has a slightly different version of the Edge controller. There are 3 different things that the platinum can do that the standard does not. It runs an O2 trim system. What that'll do is it'll take the reading of this O2 sensor, which on the standard is just for a read only. But on the platinum, it'll read that O2 sensor and it will self-calibrate the boiler daily based on conditions of how dirty your filter is, how warm your inlet temperatures are. It'll keep your boiler running at premium efficiency every day. It'll adjust it. It'll only go so far until it needs maintenance, and then it'll tell you you have to clean your filter or whatever. The second thing that the platinums have are they call it on-air technology through the I/O board. There would be another circuit board. What that will do is it ties directly into Airco's factory right to their headquarters, and they can monitor your boiler plant and let you know if your boilers need maintenance, if it sees an issue. They do a lot of proactive and preventative maintenance through that. It's one-way communication. Airco can only read. They cannot send anything to the boiler. They can't change anything. They can only monitor.
It's important to note that that would require an Ethernet cable connection as well from the building. And the third thing that the Platinum would have differently than the standard benchmark with the Edge control would be a dual return system. So when we were at the back of the boiler the last time, as we noticed, we only have one return down low. In the Platinum, we would have a second return above this. And what this would be designed for would be a situation where we may have multiple temperatures. We would bring our low temp into the bottom inlet so that it gets full condensing. And then it basically is preheated by our midsection or our second return that comes in. That might be, let's just call it the building loop. And maybe that's 140. and then we go back out to the system from there mixed. So it allows us for full condensing capabilities and higher efficiency ratings.
All right, thank you for answering that question. We've had a couple more come in. The next question is, can you tie in older Seymour boilers using the Cascade feature into the Edge controller?
The answer to that is yes.
Okay.
With the Edge one and with the Seymours, you can daisy chain them together and you still get complete communication, whether it be Modbus, BACnet, and you're going through the gateway, yes.
Okay, thank you. Our next question is, can a boiler with the Edge controller be cascaded with another boiler of older vintage without Edge controller?
It depends on how far back you go. If you go to some of Airco's older technology, if the boiler is set up and can do BST, boiler sequencing, which the Seymours have been doing for about 8 to 10 years, those can work with the Edge controller. They will communicate together and work together. However, if you have an older vintage from before they rolled out boiler sequencing technology, no, it will not work on the boiler sequencing program. You would need to possibly mount an ACS control, which will be an external control that will sequence the boilers much like BST. You don't get quite the added stuff you get out of the BST system, but it works very similarly.
Okay, thank you. Our next question is, does Airco make the benchmark in a dual fuel option?
The answer to that is yes, they do. So they make it in a dual fuel above 1 million BTUs, propane and natural gas. For anything above 1 million BTUs. The 750 and the 1 million are not a dual fuel.
All right, and our last question is, that came in is, if you were piping the boilers in a primary secondary, does the boiler have a built-in relay to start and stop the boiler pump?
Yes, it does. So there is a, this is the rib relay right here that will start and stop the pump. And you can actually set a pump delay. So you can allow the pump to continue to run for a period of time after the boiler has satisfied its temperature to obviously pull or extract the remainder of the heat out of the heat exchanger for its peak efficiency performances.
There's a tag right here that gives you your wire connections on the pump relay for the automation guys to wire into.
All right, well, that concludes our question and answer session. So I want to say thank you for attending our seminar today. We have both the Airco Benchmark 1-year and 2-year maintenance kit tutorial videos on our Deppmann YouTube channel. Please subscribe to our channel to view our videos. If you need kits for your boilers, please reach out to our customer service team at 1-800-589-6120, and they can help you get the proper kit for your boiler. Deppmann has many other educational tips, including our Monday Morning Minutes, our Service Tip of the Month, and our announcements. You can sign up for any of these on the blog section of Deppmann.com. Thank you again, and have a great afternoon.